All right, let's get started. Hi, my name is Tara, and I'm a technical product manager with Microsoft. It gives me immense pleasure to be here. This is a customer showcase session, and I'm pleased to let you all know that we have CEO of GeoSafe with us, Moshe Gutman.
Hi, everyone.
This session is all about building scalable and smarter applications using Azure Database Services. So a lot of things that you would see today in the demos, in the architecture, it's all about how we can build scalable, elastic applications using data services, comprising of SQLDB, DocumentDB, Search, Power BI, and some of the other layers. On that note, let me introduce you to Moshe, and Moshe, stage is all yours.
Thank you, Tara.
Cheers.
So like Tara said, I'm the CEO of GeoSafe. We are a startup focused on public safety software. So I'm going to give you a little background about the inspiration for our product. This is the aftermath of the 2013 Moore, Oklahoma tornado. Check that photo out. There really isn't much left after a tornado of that magnitude. The street signs are gone, the houses are clear off their foundations, and people are trapped in the rubble, and they need help as soon as possible. So when a disaster like this happens, thousands and thousands of 911 calls start to flood into the dispatch and command centers. Police officers and firefighters need to work together and collaborate. But in a disaster this large, one city's agency is not enough. And you have multiple police departments and fire departments from neighboring communities also start to flood in. So how did they all work together? How did they get all on the same page? You have this data that needs to be shared amongst all the parties involved. This is where GeoSafe comes in. We created an app, an iPhone app, an iPad app, and also a Windows app. It runs inside the police car or the fire truck or ambulance, and as the officer is driving around, they're getting notified about incidents and alerts in their immediate area. So the key problem that we're solving is data sharing. 911 calls are siloed in these legacy systems at each police department. And there really isn't a good solution on the market today that lets these agencies share data. They're all on premises, yet there is this need for sharing and collaboration of that information. So we built an app on top of Azure Data Services to help move that data from on-prem to in the cloud. So I keep saying data. Let's get a little bit more specific. The types of data that GeoSafe works with, there's 4 basic types. The geographic data. Firefighters want to know, where are all the active fire hydrants? I've just parked up. Where should I actually park the fire truck? Should it be on this side of the street or that side of the street? Show me the last 200 messages. You might think, oh, table storage would be a good solution for that. We also have traffic incident reports and tickets. You need to add 5 witnesses to this report. What is the appropriate data storage mechanism for that kind of information? And lastly, show me the current 911 calls for a particular city. Let's dive a little deeper on that one. So this is our app. It's a universal app. In this case, we're actually writing it natively on each platform. So on Windows, we use C#, and on iOS, we're using Swift. And the app is communicating with our backend REST API. Our API is based on JSON. And when we started designing this application, we knew we were going to be on multiple platforms. So we picked a communications protocol that would work well on this variety of devices. My particular focus is on API design. I read a lot about it. I look at a lot of other companies' API design, and trying to figure out what is the best practice for our own API. So if we look at this slide a little closely, we want to get the calls for a particular city. So you can assume that you would have a city ID, and you would get back a snippet of JSON that represents the calls for a particular city. So that first one, it says title, motor vehicle accident. You have a unique ID for that JSON element, the location of the 911 call, that's a police call, and any dispatcher notes and information. On the on the iPad there, you can see that first row, motor vehicle accident. That's just the visual representation of that same data. So each client, the Windows client, the iOS client, they're looking at that data and then visualizing it. And that's what the officer sees whenever they're driving around town in the police car. Taking it a little bit further, what if we just remove the city ID? So you just have /calls. What should happen? Well, we make it get all the calls that you have access to. So what does that mean? I'm logged in as an officer in one police department, and I have a certain radius of police departments and fire departments around me, and I want to be able to see their information. So I don't get to see the entire state's worth of 911 calls. I just get to see the 911 information in my immediate surroundings. So we're going to get into a little bit more about how we do that, permissions and data sharding, in the demo that we have for you. So our architecture is pretty straightforward. You have at the top clients that access our REST API. Those clients can be Windows devices or iOS devices. We also have the 911 call centers themselves. They're pushing their 911 call data into our system. Our system is hosted on Azure App Service. We were originally on web roles, and then I transitioned to app service whenever that feature became available. We've been with Azure for a while, and every time a new Azure feature comes around, I always think about how can I adopt that new technology. I'm always worried about the code that I write. I know I'm not perfect, and whenever I have less and less code, I have less and less code to worry about. So a good example is Notification Hub. We send millions of push notifications to our officers whenever they get assigned to a call or there's some emergency event. We used to do that in-house. I was using some open source framework in C# on our server, and I was always worried that as our application started to scale, would that open source library just fall over? And when Notifications Hub became available, I just deleted all that code and said, here, Microsoft, you take it over. I don't want to worry about that issue anymore. So I'm always looking at the offerings that Azure produces to see what would be a good fit for our application. Going further down our architecture stack, we heavily rely on Service Bus and Redis. I don't know if we're going to focus too much on Redis today, but at the very bottom, we have our data tier. So I mentioned all the different types of data. So depending on the type of data that we collect, we need to decide what is the best Azure service to use to store that data. For instance, officers can upload PDF files and images into our system. So a good match would be blob storage. And whenever we have traffic accident reports, we use document database. And for us, the balance between why we would use one data service versus another is really dependent on a couple of things. Cost is a major factor, but also just the ease of use of the service. A lot of our data is JSON, so document database is a natural fit because it's a JSON repository. So I talked a lot about using Azure Data Services and just using Azure services in general. And this is a really good reason why. We don't have that many developers in our company, and spending time to make pretty graphics, to track telemetry, it's not always our first priority. And you get all that for free if you just use the service. This is the SQL, Azure SQL CPU monitor, and you can see I did something wrong. I pushed an update, and it caused CPU usage to go really, really high. And then you can see at the very bottom, it's back low. And that was because I wasn't indexing some data properly, and we fixed that. And you can immediately see that corrective action is done correctly. So having all these graphs at your fingertips really, really helps. So with that, I'm going to flip it over to Tara, and we're going to talk about the demo app that Microsoft created. It's inspired, it's based on the GeoSafe app. It's inspired by the GeoSafe app, and it showcases a lot of these Azure technologies in a little bit more detail. Thank you.
Thanks so much for that, Moshe. I think you've just set the stage for the demo in the right way. What we're going to see here is, and discuss, the three major pointers. One is the easy-to-build experience. When you have an app and you have to build on top of, let's say, Azure Cloud or database systems, that easy-to-build experience is so important for any developer in any organization. Once you have developed the application, the next big thing you want to do is to go and evolve that application and grow it to have or integrate, iterative experiences where DocumentDB comes in, which is a great scenario of storing the e-ticketing system in GeoSafe. And on top of that, the last thing we want to do and achieve is to add intelligence to this application and also innovate and differentiate using visualization layer. So those are the three different parts of the demo we're going to see. As Moshe mentioned, this demo is an inspiration from GeoSafe. What you're going to see is not GeoSafe's application, but how we perceived this application to be. So we're using different Azure Data Services to build the app. Let me introduce you to the app, and then we'll take the journey from there. All right? Just 7, please. Thanks. All right. So here is our version of the app, as you can see, and let me just kind of make it bigger whenever it's possible. So we're going to log in with the details of the police officer. So as you heard, and just reiterating that, this is a real-time data sharing platform, integrated GPS, where a police department can see the position of a fire ambulance or the medical services. And every single second counts, when this is about life. So we are taking the persona of a police officer, and then we're going to talk about the whole demo. So let me log in. D. Clarkson is one of the police officers who gets into his car, and then he logs into the app. All right, and let me just take it down. So this is the initial view, and I don't want to kind of put the excitement right up there with all the machine learning thing. So here is what John Clarkson gets to see as soon as he logs onto the system. Now, as you could see, that there are moving pieces. All those small little dots, like in green, are available medical services, police services, fire services. What John Clarkson really wants to do when he logs into the system is to go and look at the responders. Who's really available, whether they're busy or they're en route to a scene. Okay. But as Moshe was saying, right, this is all about handling the 911 calls. Now, if you see on the left-hand side, there is this speeding vehicle which has been assigned to John Clarkson by the dispatch center. One of the pictures which Moshe showed you when the disaster happened, right, and the dispatch center was really busy and sending all those dispatches to the officers and fire responders and others. This is what they get to see on the screen. So let's just take a quick view of what's happening, and then we're going to show you the whole backend, that how we have developed this app. So John Clarkson clicks on this ticket here, and now he needs to navigate. All right, so let me just do Control-4 if you can't see this. And John Clarkson is right there, and he gets this ticket. He needs to go towards the scene. The few things you would see here. First thing is currently the note says it's speeding vehicle. As soon as we reach to a specific state, this notification hub sends out a notification about the updated details. So we click on that, and if you'd see now that we have more details. And there's somebody who has collided. It was just not a speeding vehicle, but they collided. There is a person who's in shock and potentially injured. Now look at this, right? There is M8 right there on the right-hand side on the scene towards where the incident occurred, right? This is what real live data sharing is all about, right? You would see that ambulance 8 will go and stop right there at the scene. Okay, so this is what's sort of a model which has been built. Now there are a few things to take from here. If you see on the left-hand side,
yeah, where are those X's?
I was thinking,
just
when did you ask
that? What are all those X's there that you have on the corner?
Yeah,
555 XXX. What's up with that?
Okay, we're trying to hide some information here. All right. So good question. Now, what we've done is, because John Clarkson is an attending officer and he doesn't have supervising privileges, we don't want to give all the details of the 911 call as such, the person who would have made that call to the dispatch center. This X's which you're seeing there is actually a feature within SQL database. Okay. So what we're doing here is, all the incidents occurring at this stage, they're all kept in SQL database. We chose a persistent storage and Azure data service like SQLDB because we want to have more scalability, elasticity, and also take some intelligent actions on top of the data. Some of this data is pulled into a Redis cache as well, just to kind of get some more quick insights.
So you can imagine security officers, maybe not police officers, would get just a redacted version of a 911 call. That's what we're trying to demonstrate here with the data masking capabilities of SQL Azure.
That's right. So let's have a look at how it looks like from the backend, right? So let me just take you to the portal and first show you what and how we have deployed these services. So this is like an ARM deployment of the whole services associated with this demo. So there is DuckDB, there is SQL, and what we have also chosen, and we'll talk about this, is the shard map. We are doing partitions, and there's a reason to do that while doing real-time data sharing.
Can you go into what exactly a shard and a shard map is?
Yeah, sure. And we'll just step into that as soon as we talk about dynamic data masking. So let me just quickly show you, once we go to the Bullis database, right, we want to go and look at the incidents. So here, we have quite a few features. Now, as I said, this is a managed service. The fabric has been created for you to go connect. It's not like a SQL server running on a VM. It's a platform as a service, completely managed so that you can go and create intelligent applications and innovate. If you see here, there are quite a few security features. So when I click on dynamic data masking, it should show me all the details of, so first thing first, it recommends some of the fields I can mask. So it's intelligent to tell me, some of the addresses are not, something which you could go and, keep that in clear text. And that's why, some of the data was masked already. But what we chose was some of the phone numbers are something which is critical data and personal information. So we created a custom mask, and you could do that. You could just go click on an add mask and just go ahead and pick up your schema, your table, and then you can just go ahead and create your custom mask here. Right? So that's what we did. We created a custom mask based on the data set and on the columns, and just saved it, and we were pretty much good to go. The few things you need to do, certainly after you've made that change, it's very minimal change. Once you have the user identified, you have to go and make connection, change your connection string. And other thing we need to do is certainly alter the column. So let me also show you what's happening from the query background. So let's look at dynamic data masking. All right, so here's what we did. I don't know if it's visible to you. Let me just keep using Control F4, Control 4. Look at this, right? What we did here to add that mask, we altered the table incidents, we added the column, and we called the function partial to get all the phone numbers masked. And that's exactly what you guys were seeing.
So did you have to do this and the portal, or you could just do this through the portal?
Either ways.
Right.
Okay.
So
we're just trying to show both the options they have. Either you go to the portal and you make that change, or if you're like more of a T-SQL person, you love writing T-SQL queries, here's what you need to do. And if you see, there is other part of the story, we'll talk about that later. I have also given a grant on master supervisor. Supervisor is a database role. And we'll talk about, when we talk about the supervising rights, which even Dodds has, who's the supervisor at the dispatch center. Okay, so let's get back to our discussion on this, right? So if you see, once we do this, and we have already masked the field, we go back to our query. So we have John Clarkson, if you recall, right? This is the guy who's kind of locked onto the system. And when he saw that data, this is what we have done. So we have put all the query details here, and we're running the query in the context of the user. And the user is John Clarkson. So there you go. Right? So now when I run this query, that's fine. Oops, all right, let's see this quickly. And the database changed, that's a good point. Okay, so let's go and run this against the Bullis database. That's where the data is, so let's go and run that again. All right. Nice. Now, if you see that, that's how the data was shown up when we saw the data on the application. So this is exactly how dynamic data masking can help you protect some of the critical information and personal information of a specific customer.
And what I love about this feature is we didn't build the masking into the API layer or the application layer. This is done all the way down to the database layer. So even if I make a mistake in production and creating my API, I know that the data is not going to leak because it's done way below from when I'm reading it.
That's right. And so the next thing we want to quickly discuss is the real-time sharing of data, right? So if you guys remember when we looked at the app, Ambulance 8 was on its scene. How did we share the data in real time? So we have used Shard Map Manager here to kind of run multiple queries across different shards with using the Shard Map key. The other way of doing this is, and we are doing this more often than not, so this is like the software journey, which most of the ISVs use today. But then there is also the SaaS story where you can have a singleton database, and then you can put those databases in a pool and use the resources. So we're going to show both the sides, but quickly maybe the Shard Map Manager first. So what happened there, right? The first thing we want to discuss and talk about is what the code looks like. So this is where the Shard Map Manager configuration looks like. We have a Shard Map Manager named Master, and then all these different shards are actually being created, and we're querying using the Shard Map query itself. All right, now the thing we want to achieve here is, I should say, the multiple shard query. Okay, so what we're going to do here is how did we really get that data set? So what I've done here is I've put a breakpoint on the Shard Map Management configuration, and we're going to go and first, execute this, and then go back to a PowerShell, and I'm going to show you a few functions. This is actually going to go and hit the code here.
So while that's loading, what was your motivation for isolating things into shards, and why did you go that route?
So two things, right? One is certainly the scale out, which is kind of interesting if you have a multi-tenant database. When you're building multi-tenant applications, one of the key scenarios could be that you have so many different customers who are hosting their data set in maybe a singleton database itself. And there are other customers who really choose one app, one database sort of a scenario. So given the fact that this was real-time sharing and we had a lot of data in like one single database as such, we thought a shard map would be a better choice for us to go and execute multi-shard queries and scale out at the same time.
Right.
So the partition scale.
And to go a little further than that, you make a choice whenever you're designing your application. We went with shard maps here, but from the customer's perspective, it's all the same. Correct. And what I like about having a cloud service is, we decide, maybe table storage is a better solution or SQL is a better solution. The REST API remains the same, so those changes are opaque to the end user. So we're always changing our back end to utilize the correct technology or a better technology as we learn and adapt and see different performance metrics. So don't feel like a decision that you made on day one is you have to stick with that.
Right, and that's the best part, right? I mean, the way when you were creating the app, you had a certain way of looking at the Azure Database backend. When we perceived it, we had a different notion. So the ingredients could be different, but at the same time, what we want to achieve is greater scalability, elasticity, and the way to evolve and grow that app. Okay, so while we executed the breakpoint, I just want to quickly show you that what we have done here. So let's Control 4. We have imported the module for shard map management, and this is like a quick one. So you import the module, and then this is how the shard map manager is getting data across different shards. Okay, so we're pulling the data from the SQL Server. Then we are using the range shard map. The name of the range shard map is incident shard map. So it's kind of looking at the incident database and then sharding it across different and multiple databases. Now, the next thing we want to highlight is what are the different modules you have within the shard map management. So if you kind of go and execute this piece of the query, you get all the listing. So you've got list mapping, range mapping, and the range shard map, which we're using in this particular scenario. Okay, so let me just go and invoke the REST method, which is going to go and hit the breakpoint, and we'll just go from there. So I'm just now executing this.
So we're simulating a call to the API.
Absolutely, yes.
Right.
Now that has hit the big breakpoint right now. So if you see, you can just go and do a step over, and it's currently looking at all the arrays within the shard. And what we're going to do is we're going to go and hit the execute multiple shard query, and I'll show you what shard it's going to hit in general. So let's go and do that. Okay, so that's cool. So that's where we stand. And then if you go to shards, And if I expand this, right, and let's say we look at this and, sorry, my bad.
So we're executing a query across 3 different shards of the database. So you run one query and you're automatically getting data from all these different shards and then collecting them all at once.
That's right. So if you look at this, right, so when we are looking at that shard function and trying to look at the location and the details of it, you would see the data source, which is certainly the SQL instance, and then the database itself, or the shard itself, picked up from there is the AMBO. So when John Clarkson was there and he was on the scene, we kind of executed this query across different shards, and that's how Ambulance could see the data and was on the scene at the same time. Now, all the shards are kind of online, so which is good. What we need to do is, from here, we're going to go and do a query helper, and that should take us to the next place. All right, so that's, or I should just go and execute. So let's go and look at the PowerShell. Sorry about that.
There he is.
Good. So when we kind of hit the execute multiple shard query, it went and it executed the query against all the shards we had available. So if you look at this very closely, most of this was all from AMBO or FIRE services. Certainly we're not going to query the police database or the incident shards because they already have access to some of the data set. But if you see here, this first data set is coming from AMBO, which is the ambulance services. And if you go further down, you would see some of them is from FIRE. There you go. And that's how the real-time data sharing has been happening. So that's how we perceived it and thought of implementing that into the app. The other way of doing this is if you have singleton databases and the apps are running on those, like let's say for police you may have separate databases and for ambulance separate, and then again for fire others, then you can put those databases in a pool. An elastic pool is a concept where you can share resources across databases. For an example, you may not have a lot of load coming into fire services or ambulances, but then there's a humongous amount of performance impact on the police database per se. So what you could do is you can put all of those databases in a pool and share the resources so that at any given point in time, none of them are out of resources first, and police databases do get enough EDTUs, or we call it database transaction units, to go and request and kind of cater to the request coming from the applications.
Okay.
Right?
So if I want to learn more about shards, where can I go on the Azure website to find out?
Yeah, if you go to azure.com and go to SQL database, you can learn more about shard map management. All right. So the next thing we want to do here is the customer isolation. So one thing we probably didn't discuss is what if there is this, and I think this is part of your app as well, there's a jurisdiction where let's say John Clarkson or some of the police officers should have access to. Let's say region code 98052. Right.
Specific.
But then he should not be able to see the data of another jurisdiction, kind of where somebody else is responsible to take care of that. How do we go and create that custom isolation is another big piece to solve. So that's where we have, or we bring in row-level security. So let me just quickly show that to you and how it all works. So for row-level security, the big thing is, certainly we have to go define a specific function and then define what the function is going to do. So what we have done here is, if you see very closely, that we have picked up, so supervisor is a database role, which I mentioned initially, that if the member who's logged in and looking at the data set is a supervisor, then definitely don't go and restrict him from seeing the data, because he should be able to go and see any data across jurisdiction. But if the username, the function is based on suser sname, so eventually if John Clarkson logs in, then he only gets to see specific data from a region ID. Right. The region ID here is a postcode.
So what we're getting at is, depending on who you're logged in as, you may only have access to a certain set of data, and you can implement that using row-level security.
Right. So let's have a quick look. So this is how we defined the policy. So the policy says it's policy incident, and then whenever the state is equal to on for incident stable, we're going to go and execute the rollable security across a specific SUSRS name. So let's have a look into what's happening here. So per se that John Clarkson logs in and he needs to see certain specific region IDs. When you run this query now, after you have set up the rollable security, and once we execute this, he only gets to see data from these region IDs only, right? And similarly, when you would go and execute the incidents based on that particular user set, you would see that all the incidents are only from those two region IDs. So even if we go and do a select star from all incidents, he only gets access to that particular region ID. Mm-hmm. And it's the same for, let's say, some other officer who's got jurisdiction of other city in the state of Washington, per se, right? And then when I go execute this guy, same thing. So he's got some other region IDs, and when we go execute Ben M's queries on all incidents for Ben M, it will be specific to those region IDs only, right? So this is how, even though you're running, multiple different departments within the same database, but you're still kind of ensuring there's a customer isolation using rollable security.
And at GeoSafe, it works very similarly. Whenever there is that large-scale disaster, a supervisor can go into our dashboard, turn on a couple of agencies, and now those agencies have access, or those officers have access to those agencies. And this is a way to implement a feature like that. Yeah, there's a question back there.
Yeah, we can make that available, that's fine.
Oh, this is actually from the example, so this is not from...
This is our demo app, so we can definitely make that
We did that on purpose.
Yeah. All right, and we'll get back to the other scenario. We'll get back to rollable security and dynamic data masking in this sometime. Yes, sorry.
So just back to shards for a second. I noticed that your web API calls weren't async. If this was production, would that be a consideration for you, or
yeah.
Yes, or
yeah, absolutely.
And as far as the role level security, would you envision that being also enforced on the web API level as well, or would you just defer that completely to the database?
I think that's like on the database side of things. So it's completely built into the engine, especially RLS, DDM, all of those features.
So you won't have an issue with
Nope.
the coupling that would happen? Or?
No, I think it's...
Yeah, I mean, it depends. So it really depends on your use case, right? If all your data is in SQL, then that's a good solution because your roles are in SQL.
I guess like in your case,
Yeah.
there's like several disparate data stores.
That's right. So there we actually do it in our API level.
Like you have an abstracted repository? Or?
Yeah, we have like a permissions database. Right now, it's basically triples of data that's stored in SQL that say what roles each officer or agency has. But yeah, if we were fully SQL, then we could do it more like this. Makes sense. The first question he had was actually about async, whether we should use asynchronous queries or not. I would say yes, we do that in our production code. Wait.
Yes.
Comparing dynamic data masking to stored procedures and shards, why would you choose to use dynamic data masking and then this row level security when you could use stored procedure and effectively do the same thing? And stored procedures are long around a lot longer, and you could get more people who know them easier than you can get anything else. Is it just that you can't use stored procedures over shards, or is there some other kind of reason?
A good question, actually. I mean, from what I know, and you guys can pitch in if you like. So we also have our product engineering here. If they want to pitch in, they can. So from my perspective, stored procedure level, you're still writing that piece of code. So defining functions and deriving that, and then again, it's a stored procedure, so it needs to be recompiled when there is a change. What we have done is these features are built into the engine, which means when you go and you create that feature set and you enable it, it's there on the engine already. So you don't have to go and write a piece of code. Is that right, Ron? Or
Exactly. The dynamic data masking is a built-in. It saves you the idea that you do it that way. It saves you a lot of time
Okay.
and do it in the application layer, as Moshe mentioned, and other layers. It works for stored procedure. It works for everything. So basically, it reduces your development time to minimum without
Yeah, the question is why to use data masking versus a stored procedure that can achieve the same row level security. Yeah, I would think just avoiding mistakes would be a big reason that, okay, I need to always mask it, but maybe this one stored procedure that I wrote on a late night on Friday, I forgot to mask it. So since it's in the database layer, it's always masked. You don't have to worry about that. That's what I would think.
It's agnostic to a lot of applications. If you have
Correct.
several applications, you have a web application, you have a mobile application, so you don't need to worry about always the database that you work with.
I think it's minimal code changes as
Yes,
well, right?
exactly.
So, yeah.
So does that mean that anything that you could use dynamic data masking, or you could use, like you could shoehorn in your, effectively your Sprox into row level security, you should always choose row level security over Sprox if it could be done?
It's a good question.
Yeah, it's basically we assume that this is the simple way to have. Basically, you can look at data masking and one of the security has two similar functions. One of them is mask data by rows. One of them is mask data by column. And automatically, it's run the queries that the server does for you. So we think this will be simple things for you to do it. Doesn't matter if you're using stored procedure, generating your own SQL statement. This will be the least effort from your side as an application developer. But again, you can choose to do it by yourself. This is an option that is available for you.
Right.
And then just quickly to address your question on shards. Shards is just synonymous to database, and the shard map management client libraries are a data distribution mechanism that is a client library that you can adopt so you can focus on your application code and not have to focus on how am I going to distribute this data so I can achieve infinite scale, and how can I achieve data-dependent routing so that when any tenant comes in, they get routed to the correct database.
Right. Any more questions? Yep.
So what is the performance if you use a row-level security?
That's a very good question to have.
Using the RLS and dynamic data masking, it's reduced the performance to minimal because it's done as part of the engine. So when the engine runs the query itself, it's done internally, and you don't need your application to waste a compute in order to do this manipulation. So this is, by the way, another why do we use the engine?
Good point.
Yep. Go ahead.
So to follow up on this question, if you use data masking, is it going to use more data? More data?
Latency?
Latency?
Data.
No, like storage.
No.
Think about it is the server is taking your query, and before it brings the results to the clients, there is some manipulation that is done, so the sensitive data will be obfuscated.
Would you say it's like a transformation?
It's in real time. It's dynamic. That's right. It's called dynamic data masking. Okay?
So you don't store data somewhere
No.
else?
The data is stored in the database.
Completely in the engine.
In the same format. Only when someone application is trying to query, the engine starts working and do the manipulation and masking.
And one thing we're not touching as part of this app at this stage is always encrypted, which we haven't talked about.
Yeah,
But
there is.
it's a different notion.
This is two examples of security features. If you want to use an extra security, so another option is you can encrypt the data. So, for example, for high sensitive data, it might be more effective to encrypt, and also this is built in the engine. And all those features, masking and encryption, we are talking to a lot of customers. It took them weeks and months, and when you have it available in your engine, it saves you, as also Moshe mentioned, so much time. So again, what we want to have is allow you to focus as also thorough on the application and save you all the burden of doing it yourself on the application.
Great questions. And keep them coming. We want this to be an interactive kind of Q&A. Yeah.
Cool. Let's keep moving further from here. So we'll get back to row-level security and dynamic data masking in some time when we talk about when even Dodds, who's one of the supervisors who logs onto this app, and his experience with the app. So let me just kind of shift gears and show you some of the things that Moshe was talking about. There are certain recommendations which we built into the database, as we call it, the intelligent database in the cloud. If you remember the last screen which Moshe showed, where he was dealing with a CPU issue, and he had to go and implement an index. Okay, how do we go and create the state-of-the-art sort of recommendation engine? So let's go and look at the portal quickly. So here you saw the dynamic data masking. We have something called as Workload Insights, or we call it SQL Database Advisor. Most of you might have used, if you have ever worked with SQL, the Database Tuning Advisor, which is to give you a lot of recommendation on stats, indexes, and whatnot. But here, what we're doing for you is we are collecting all these telemetry and workload insights. And depending on your workload, we are recommending what could be a great performance improvement. So per se, when I click on this database and when I look into this recommendation, I could easily see that based on the queries I've been running against the database, I have a high chance if I create, let's say, an index against one of the tables, and this is just this demo part of doing workload insights, then I may have a great impact in terms of my performance, right? And you can just click on this further, and it'll give you all the recommendation details, how much disk space it's going to take, whether it's a clustered, non-clustered index, and what sort of index key columns you're going to be using.
So this is Azure SQL, analyzing my queries, analyzing performance of my database, and also making a recommendation about maybe a change that could improve the performance of my app.
That's right. And then you can kind of go and look at the script if you like to go and apply it, and you want to just go and figure out if that's the right index you want to go create. So the validation could be done right there over here on the screen. The other way is that you can go and click on apply, and that index will be applied. So now you're saving a lot of time, and that time could be used to create innovative applications, and the whole thing on the back end is completely managed. The other thing is, which goes kind of hand in hand with workload insights, is your query performance insights. So per se, I'm already running some workloads here, and if you look into this, the query performance insight will let you decide the sort of queries you're writing, if that's kind of really good or not, and if there's a latency or there's some more CPU cycles it's taking, the execution counts, and in general the whole usage on the backend. So we are running some workload, and as you could see, when you enable query performance insight, it starts collecting all the details of your query consumption. I don't know if if somebody here is from SQL Server background. We used to run a lot of tools like PSSDiag and run SQL Nexus, and then used to get all these details. But look at this beautiful way of collecting all the telemetry and then recommending what could be a great query plan for you. So you can just go and look at the query, fix the query if need be, and based on the workload recommendation, you can go maybe let's create some stats or drop an index, create an index to kind of benefit your query performance from. Right, so just want to quickly touch on that, and then we should just go back to, let's say, the app again. Is there any question on these two pieces at all?
Do you have any tools that I can see what queries are being executed as statements here?
Yeah, sure. So I didn't show that, but when you click on, let's say, the query ID, it will show you what sort of a query it was per se, right? So when I click on that, it shows me this is the query which was running, the details, how much CPU it's been taken, in terms of the aggregation we're running on the backend.
Let's zoom out
Last
a little
24
bit
hours.
so we can see.
Yeah, sure. And then you can further go deeper based on specific spikes.
Is this real time or?
Yeah, it's real time.
Okay.
Does it have like history of the queries that are being run, or only first time?
So I think this is running on the backend all the time. So it's collecting the data and then.
Go and see yesterday's queries like that.
Yeah, you should be able to go and reuse the time frame and work with it. So this is just kind of an insight quickly into it. Probably I don't know if you already had some sessions at Ignite on performance recommendations. So yeah, those would have been the best sessions to go and take a deeper dive. Oh, cool. Okay. So on that front, let me just go and get back to the app, given the time frame we have available to us. So when we were here, right there on the app, we stopped, right? And if you see, there is this polygon. What we did was we started looking at two different, very crucial information here. First, the sort of incidents, right? When John Clarkson has reached a specific location, he really wants to be sure how this place is, whether it's very incident prone or whether there are other issues which is going on he needs to be aware of. So there are incidents which you're seeing right there on the screen. But then also, we wanted to take an option to figure out whether a ticket may be issued depending on where he is at this moment. So this polygon is actually coming out of the document DB's GeoJSON capabilities. We'll show you how we have worked with the longitude, latitude of the details. And we did the same for SQLDB, but we chose document DB because our e-ticketing is all stored in DocDB. Okay.
So you're performing a geographic query against document database.
That's right.
Okay.
And like if anybody wants to go and play with DocDB queries, there is a query playground on the DocumentDB page, which you guys can get access to just to get in some more interactive experiences. So right there, we'll talk about the backend. But before that, let me just also figure out what's happened on the scene, because we're still going through the whole story here. So when John Clarkson reached the incident place, this guy was severely injured, and he was not certainly carrying his license or ID. So John Clarkson questions the guy and says, "Sir, can I get your name?" And this guy says, "Joe," and something. So the thing is that because we have a humongous data set available to us from a e-ticketing perspective, which is stored in DocDB, what we have done is we have built Azure Search Catalog on top of that data set. So let me go and click on Identify, and this is what we're going to do here. We're going to go identify this guy just in case this guy exists in our database at all, right? There are a lot of things being used. We'll talk about facets. We'll talk about phonetic search. But this is what happens when he clicks on Joe and just wants to see whether this guy belongs to this area, and it comes in his database. All right, so when we do that, we get some recommendations. Right? This is all coming from Azure Search. What John Clarkson figures out that this guy looks very much like Joe Cascaro. What we have done here is, and I'll show you the backend in a moment, we have used a custom analyzer called phonetic search. These are similar sounding words. So maybe the best part is we have our principal PM. His name is Liam Kavanagh. When I say Kavanagh, you can say Kavanagh as in K-A-V-A-N-A-H, or maybe C-A-V-A-N-A-U-G-H. So similar sounding words could actually have a huge impact. So how do we go reduce that and filter the right information? So this is where we use phonetic search, and I'll show you the whole code base on the backend. We figured out that this is Joe Cascaro, who looks pretty much exactly the guy who we are seeing from that area. And he has some tickets in the past as part of some incidents. So we just want to go and click done, and we're pretty much good to go here, right? So once that happens, we're going to go and talk about whether we should go and initiate a ticket or whatnot, but that's kind of a little late. But let me just show you what happens in the backend here. So two things. We're going to see how the DocumentDB is storing the data set, and also how search is built on top of DocumentDB data set. So let me go and log on to the DocumentDB. Oh, that's the DocumentDB query playground, just for your information. I'm going to go back and get back to my resource group. And that's where I have my DocDB store. As you could see here, that this is like very interactive sort of a service. You can have a query, the Query Explorer, where you can go ahead and run query against your DocDB collections. And what I'm going to do here is click on Query Explorer, and we have a few queries to go ahead and execute. Okay, I can go run this query right now, and that'll go and give me details about all the tickets I have or issued so far in that region, right? So it's giving me all the coordinates, where my position is, and when I issued the ticket, right, and what sort of a ticket it was, and et cetera, et cetera.
So at GeoSafe, we spend a lot of time thinking about should data go into SQL Server, into table storage, or into document database. For tickets, we chose document database because of the variety of the data. So for instance, a ticket, or more specifically a traffic accident, can have multiple witnesses, like 5 witnesses, 6 witnesses. And yes, you can create a witnesses table and join it, but it's really important for us in our use case that all the data be collected as one unit. This is just to make sure that we don't mess up the data by editing some row in SQL. So we have it all together as one unit, and that's how we think of it. Kind of like a paper ticket has all the information on one page. Same thing in document database. And the second reason that we did this is different cities collect different information on their tickets. It's difficult to do that in SQL Server, to have variable columns. So here we can accommodate that. The university police need to collect the student ID, but the county sheriff's office doesn't. They don't deal with students, they deal with citizens.
spot on. And as you could see, when we talked about the polygon, there was a big piece of GeoJSON which was involved. So what we're going to do is we're going to run and show you some of the functions we use within GeoJSON. So let me go and pull that up from here. So let me go and capture this query. All right, and I'm just going to go and execute this right now. OK, so as you could see closely, that we are looking at the polygon coordinates, and that's how we built the polygon. So this is the query when you saw that picture on the dashboard of the application. ST within is one of the functions we're using for location details, and that kind of figures out all the longitude, latitude information coordinates for you. When you go and execute this right now, and I'm going to go do that. Oh, query completed with errors. Did I copy something wrong? Oh, sorry, we just copied, or we didn't remove the first one, which is OK. Sorry about that. Yeah, so you can't do these multiple queries here. OK, when we do this, and then you would see that all those details starts coming up. There is this type of point which is telling you where exactly the location of police officer is when he kind of issued the ticket and when he was moving. So all of this data is actually coming from there. And what we're going to do next is we're going to go pull up another two function calls. There's quite a few different functions which are used to go and look at the GeoJSON capabilities within DocumentDB. The other one we're going to quickly look into is the ST distance. The kind of distance where John Clarkson is currently from, let's say, the call made by somebody to the 911 call center, or the ticket which was issued nearby to that location.
So this is great for reporting. Maybe a supervisor wants to know how many tickets are happening at this intersection, or how many incidents happen within 5 miles of this region. These geographic style queries are really valuable.
Absolutely. So different ways of running this query, and as I said, there are a few more options you could use to create GeoJSON capabilities in different functions. On that note, so that's where the e-ticketing information, but one thing we probably need to also mention is think about the ticketing information could be very specific to a region, right? They may be using tickets for storing, let's say, student ID information rather than the driving licenses and whatnot. So that's where the JSON capabilities could be very interesting, that you don't have to go build a schema. And the other point is the data will be actually pretty humongous. Just imagine if it's across the United States. You need to get that millisecond sort of a response and throughput to get this data back from DocumentDB. And it's the elastic scale which it provides is super awesome. So that's another thing which we want to go and highlight here about DocDB. So the next thing from here, if there is no question, yeah, sorry.
How many records did that query run through there?
How many records? This is a demo app, so it's kind of not too many, but still it's pretty big. But in general, when we do the performance testing, I think it's humongous amount of data set, which comes back in like milliseconds. And we do have some of the performance benchmarks which has been done, and I think that's there's a performance benchmarking GitHub solution which is available. You can actually have a look. And there's also some of the programs we run to kind of go and benchmark and show you how your data set and workload can be executed against DocDB. All right, okay, so I'll keep moving. And the next thing, if you remember when we did the search on Joe and Azure Search came up, we want to go and talk about Azure Search. So let me just show you what Azure Search catalog looks like, right? So Azure Search has its own catalog, and what we do is right here. So when I click on Azure Search, when we import the data gets imported from DocDB to Azure's own cache, and that's how the indexer is built on top of that data set. So if you see here, we have built a specific indexer called people. And when I go back to my code base, let me just kind of shift for a moment to that. So when I click on person.index.json, you would see that there's a lot of insight where I think one of the things we mentioned was the phonetic analyzer, right? So, but then also the squaring profiles. So when I go further down, this is how the scoring profile has been created. So if you have a look closely, there is this field name, which is the home location. The reference point is where exactly John Clarkson was. So eventually from there, anything to kind of go and boost the scoring profiles to get better information about the tickets and the incidents around that area, that's how scoring profiles could help. That's a feature within or built in within Azure Search. Now, when you also look at the custom analyzer, so that's just to mention that how we defined it. If you remember phonetic search, where we were looking at similar sounding words, that's how you go define the custom analyzer, and then you will name that phonetics, and then put that in the actual JSON file to kind of call it. So next thing we want to do here is how search works, and how is it really looking at the reference point, how the scoring profiles have been done. So let me just jump into the Visual Studio and quickly show you that piece of information here. So
while he's bringing that up, I want to just mention, it took me some time to figure out what the difference is between search and just doing a query on the database. And that phonetic search is really what nailed it home for me. The database says Joe, but I typed in J-O or J-O-E or even Joseph, and having that, that's the difference, that you're doing kind of like a fuzzy type of searching, but it's a little bit more advanced than that. You can do all kinds of analyzers and stemming, and it's more than just querying your data set. And you can also query your data, or you can build your index from multiple data sets, not just doc database, but also SQL.
Right. And when you look at the indexer, you can also customize and schedule it. So you can run the indexer by default every 2 minutes to 5 minutes, which will kind of capture all the data from different data services, and then go and build the indexer.
Right. So it's like a search engine for your data. So you can adjust the ranking and the scoring and things like that.
And so we're going to see two things here. We're going to talk about facets, which is like kind of a filtering. And the other thing is the scoring parameter. So the scoring profile is what we're going to quickly have a look at as part of this demo. So I'm going to go and hit the 5 on the breakpoint, and I'm just going to go back to my PowerShell. So when I'm on the PowerShell, what I want to do is I just want to go and call, so invoke the REST method again. So this is what we're doing. And if you remember, we looked out for Joe, right? So that's the search text. And we want to go do a good boosting on the scoring profile. So when I'm here, I'm just going to go and execute this guy. Now what this should do is it should go and hit my breakpoint. So it has done that. And let's just go and quickly scan through this. And if you have a closer look into this again, there's also geolocation caller details on longitude and latitude, which is coming from Azure Search. So that's another way why it's so helpful to support SQLDB, DocDB sort of data sets, because it supports geolocation as well. So the next,
just to interrupt for a second. So what you're doing in this scenario is you're providing a position. I'm searching from this place, and that's affecting the ranking of the search results I'm about to see.
Spot on. So when I do a step over, so that's kind of where the search mode is kind of executed. And then if you look at the scoring param, it should show you all the reference point details. So it has already hit the reference point. Now if I go execute this and go back to PowerShell, so it has already hit the execution point, and then I'm just going to go and run the result set. So when I do this, what should happen here is it should give me a detailed scoring highlight. So if you see, now we have got 48% hit, and Joe is right on the top of this output.
Right.
So eventually, anybody who's with the name of Joe would actually have a great scoring profile, and we'll highlight that on top of the document.
So you can extrapolate this to a police database. I'm looking for a suspect, for instance. Well, all right, there's maybe 20,000 people in my database or more. Which one is the top rank? How do I rank those results? It's more than just querying. It's also ordering that data so that you can make a business decision.
Right. Cool. And then the last thing is, how did we define the facets? So the facets are based on certain parameters and filtering we've done, right? So when I run that, because we already hit the breakpoint and can do the execution, so you would see that this is the sort of filtering we have enabled. So it's completely based on the sex of the female and the male, or whatever it is, and then based on that value, we look at the counts. And that's how, when you saw the results, I don't know if you remember, they were also, if I click on identify and just type in Joe again.
So those facets help you further subdivide your search results. So,
Right, so
I'm
it's-
looking only for hair color of this type or gender of this type.
Yeah, so it's basically the facets were based on the gender. So eventually you have females or males, and both of those are part of the facet and the scoring profiles when we executed that search query.
Well, let's open up the questions. Or...
Cool.
Yeah.
So the other thing is we still left with the even dots. So when even dots, who's the supervising police officer, he logs into the system, his experience with this whole app is exactly pretty different. So we're going to go and look at that. So let's click on this guy, and I'm going to log in with the supervising police officer's credentials. So when EvenDodge logs in, he sees a very different approach to this, right? So when he clicks on this data, if you see, all of this data now is in clear text because he's got supervising database roles. So dynamic data masking or row-level security, if you have admin privileges, you can see the data in clear text. And that's why, security is at the realm of people who have got very high privileges in an organization, right? So, but then what we really want to highlight here is two things. Now, we saw the dynamic data masking is kind of taken care of here. But if I go to my query and look at row-level security, if you recall, that's where we wanted to be. Now, here is when I run the same query which I was running with using even dots, you would probably see that there will be no results because even dots is not given any sort of jurisdiction based on the region ID, so that user credentials has not been assigned. Now, what we are going to do here is select role member supervisor, which is a database role, and give that to even dots, and go and execute this query. Once this has been done, we know it's all good. Now, if you go and execute this query against even dots credentials, he gets to see every other region ID's data. So as a supervising police officer, when he needs to go and dispatch those incidents, he needs to see where his officers are and all the regions as such. The other thing we also thought of implementing, and we kind of got there, we're going to just share a bit more of it today, is this particular dashboard, right? When even dots is here, and I can just kind of click on this. Oops. Fair. So we'll just quickly have a look at that in a moment. Fair. So when we're here, the two things even dots could see. There is these areas which are very prone to certain incidents. If you see on the left-hand side, these are like pretty deep yellowish or orangish. It gets red. So that's kind of gives him a good amount of idea that particular jurisdiction is under some sort of higher incident rates or whatever. But that's like a quick map which we have created. And how we have done this is we have actually built a machine learning algorithm, right? So what we're doing is there's some data sets which are coming from the 911 dataset.csv. That's where we have stored. And then we kind of go through this process. This is a linear regression and regression sort of an algorithm. And then once we put that algorithm in place, we go ahead and execute and put an output as a web service input to this whole application. And then on top of Bing Maps, there's an API we have used to kind of go and build the heat maps, right? So this kind of gives him a good amount of idea that which jurisdictions are under a lot of incident threats at this stage. That's one piece, which is like a quick intelligence built into the app. But then he also needs to look at the e-tickets. He also needs to look at some of the other aspects of this data sharing and also the 911 data and take intelligent actions. What we have also done is we have built a Power BI dashboard. So what EvenDots also gets to see is this, right? He gets to see all the data which is stored in 911 data set, which is stored in SQLDB, all of those current response times, the 12-hour incidents by priority. There is also some of the word cloud we have built, and also some of the incident locations which are prone. So there are two ways of doing it now. One is through the machine learning we have built into the app, and also from here in the dashboard. The other thing we also did a bit of research was on how do I get real-time data on the dashboard? Because currently SQLDB doesn't have like a adapter to the Power BI to get that fixed, done. So what we did, we kind of created or worked on a REST API of Power BI to integrate that into the SQLDB data. So here's what I'm going to do quickly. I'm going to go and run this BitLoader. And that should hit that particular guy. Now, what you would see there is, because of this is all pretty much now gone to 0. And on a 5-second basis, I should be able to receive data from different data sets, which is available on the SQL databases for pull-list incidents, fire services, right? All of those incidents are now coming in real time. So I could see what's the current response time to one of the incidents by the officer, how many of them are unassigned at this stage, and you would see how many of them are currently high on priority incidents. So all of that will keep changing. So this is like a real-time dashboard, and we use that. We created that using Power BI REST API connected to SQLDB. And when you see this further, there's some more information. Which officer is on scene, who's available, who's kind of overshift. There's a lot of details the officer could actually go through to figure out how he needs to place his officers in different locations. Also, some of the events can have more of the police officers going to that place. Is that how you perceive that as well, Moshe? Or?
Yeah, we don't use Power BI today, but yeah, you would just connect Power BI to our API and allow non-programmers the ability to look at that data in different ways. Can you go maybe give a little background about Power BI in general, what it is and who would use it?
Oh, sure. So this is like our visualization technology. How many of you know Power BI? Most of you.
Yeah.
This is great.
Now, related to Power BI, I thought you can do like real-time analytics by using direct query mode on top of SQL and DW.
Yeah.
So I did not get exactly why.
Okay, good point. So this is all the data is stored in SQL database, and we have to move it to a data warehouse and then run a Power BI. And what we did was we were trying to figure out what's our best bet. You could do a lot of analytics on SQLDB using machine learning, which we did, but an R is currently not available. But if you have to create a visualization layer, then you have to have a REST API somehow connecting to Power BI, to a SQL database.
I want to understand that direct mode, direct query from Power BI cannot access directly SQL.
That's right. And basically the schedule or the real time. So what we wanted to do, you can still go and pull the data. That's not a problem. But having it running in real time or updating in real time is where we kind of got stuck. So we used Power BI REST API to pull that. So today if you go and click on Get Data and pull up something from, let's say, SQLDB per se, it'll stand there, but it won't be like real-time data. So how do you kind of get those gauges moving? So then that's where we did the research and figured out Power BI REST API could do that job. Yeah, it's a kind of a different approach to it. So hopefully once we have those analytics built in, then it'll be easier.
So I switched it over. So we covered quite a few technologies today. Some of them we do use at GeoSafe, some of them we don't use yet. And that's kind of the point, that you pick your mix of technologies and whatever is appropriate for your particular business.
And these are some of the things which you could do. We'll go and package this and put that in GitHub for sure, the backend. And these are some of the resources if you really want to go and get your hands on into the technology. So these are all available applications. You download this and you're pretty much good to go. So just git clone and just open up your Visual Studio and you can just start building these applications. Sorry? Yeah. Oh, for this application? No, we will just probably, certainly GeoSafe can, but for me, it's more about the backend, which I can share for sure. Yeah, and we'll see how we go. But these are some of the resources you may want to use to go play with this technology. And as Moshe said, the idea is to give you guys an option to use different data services to build the application. GeoSafe did it in a way. We kind of took some of the inspiration from there and then added some of our features to make it more scalable, elastic, and smarter.
Well, ours is pretty smart.
Oh, awesome, it is. No doubts about it. Any questions, guys, before we kind of wrap up? How did you find the app? Was that okay? It was just our way of perceiving it.
Sorry. It's hard to see.
Yeah.
It's pretty bright.
I suppose the question is, and I know what the answer is, but plan ever in the future that the support, the new embedded JSON support an SQL server.
That's a very good question. I think, see, how I see it. I mean, this is just my way of looking at it. The JSON thing in SQL Server, it makes sense because if you have SQL Server customers who want to have relational data store, but still want to have the capabilities of a JSON, so that if they have some data which they want to store there, it's okay. That's why we bought in. But then certainly DocumentDB's architecture is very, very different. It's been created for great partition scale, elasticity, and I can't compare or comment on the performance. As I said, we can do workload analysis and run some performance benchmarks for you. But comparing those two could be very difficult at this stage. Even I don't have any data set on JSON running on SQL Server compared to DocumentDB. So I don't know if that answers.
I kind of feel like it's about pain too. Like if you already have a lot of data and you're trying to add something to it and not transition your entire application to document database, then it's a good stopgap. So that's how I feel about it.
I'm just thinking in terms of with document DB, there's size limits with the document you're storing in 512 KB or something like that. When you're building up, say, parent-child relationships and things like that, you're going to hit the buffer size and overflows. What you do, how you handle that, start to spit those records out. It goes back to the SQL Server model.
Right.
Trying to implement something semi-relation in there. Any ideas how to get around that kind of stuff in a document DB perspective?
Yeah, I mean, see again on the DocumentDB side, there were limitations initially, but I think there are some partitions which could be really as big as 10 gigabytes and above. So that kind of you have limitless scale. So we have taken care of those pieces. Latency was another thing which people used to kind of mention, but latency is super awesome. I mean, you kind of very reduce latency on DocumentDB stores. Some of the customers we know of who are using DocumentDB and in a major scale, or could be a scenario for those is look at some of the e-billing thing, right? You have so many different like billing for your app, phones and whatnot. Where do they get stored? You can easily store them in DocDB, but you're looking for a specific data set. Let's say 2015 at this time, I want to see my bills. And you want lightning fast response to it. I think the managed service built and the algorithm built or the whole architecture built in DocumentDB is pretty fast compared to relational because you're just querying the JSON data. And relational, you have to go and query, go through foreign key relationships and whatnot to get that data access. So you will always have a bit of a time frame in terms of the latency. So those are some of the criteria. And as I said, compared to what you're asking, I could also suggest you could use data lake. You could have relational, non-relational, any data in its native format, and then build Azure Data Analytics on top of it, Data Lake Analytics on top of it. So there's different options you could use. But I don't know, Sham, if you want to add something.
One thing I can add about the document size itself being 5.3, that's optimized based on what we're actually seeing as patterns, but we do have customers that are using larger limits. If you need, you can contact me or Tara and we can actually help you with that. Mostly in terms of the designing of the application as well as if there's a need to actually see larger documents, support larger documents, you can do that. One of the reasons is because as you know in DocumentDB everything is indexed automatically, there's no need of a secondary index. And based on the patterns we have seen, we have come up with an idea of is what an optimal document size looks like, but we can do that.
Good point. Yes.
We actually have a session tomorrow that talks about some of the DocumentDB design patterns, and we can talk about that.
Yes.
So, follow up on the previous question, that question about the presentation. Is there a comparison currently between the new JSON format that goes into SQL and the XML format? Because the queries that you write look nearly identical, and we shove a tremendous amount of XML at
SQL.
SQL.
just to get a huge clog in there to process it.
Yeah. No, I think at this stage we don't. From a SQL Server perspective, I haven't heard of any performance benchmark for JSON support. It's a great question. We know the contacts whom we can go and approach. Is there a way we could get your contact so that we can get you some details there? Yeah, that'll be awesome. Yeah.
And then on the presentation, is there a way to move for the elastic pools between pricing tiers?
It's
I went to your presentation yesterday, threw all my databases in a pool, and it was great until I got
So there are,
sit there for an hour.
the-
You can move between pricing tiers, between pools, it's simply either through the portal or an alter statement or REST command.
Can you show me that afterwards? Because I couldn't find it.
Okay, yeah.
Because I would have absolutely upgraded my entire pool.
Yeah, configure pool, I'll show you.
Yeah, I just didn't see it.
Okay.
Thank you very much.
cool.
Thank you.
Any other questions, guys? Great. Thank you so much
wait,
for,
we got-
sorry, my bad.
we got one more.
My bad, my bad. Go for it, go for it. Go ahead.
I just noticed that there isn't a document DB booth down in the Microsoft section under Azure. Is going to talk SQL Server booth, is it?
There is one for data management.
Data management board.
Yeah, it's the same, actually.
The class services and there will be somebody there. Actually, I'll be there right after this session. Yeah, so.
I was like, so I went.
Thank you, everyone.
Thanks so much, guys.